Just take a look at a couple example problems from 2.7. Both of these are in your packet that came for 2.5 through 2.7. The main thing we're going to focus on today is when we solve equations, when we're dealing with multiplication or division, you have to remember, you have to honor the original equation in that we can't divide by zero. So the one slide says when we multiply or divide an equation by an expression containing variables, the resulting equation may not have solutions that are not solutions of the original equation. So the main thing we're focused on is we want to make sure that we don't have division by zero in the original problem. Otherwise we have extraneous solutions. For these reasons we must check each solution of the resulting equation. So you have to go back and check your work is basically what it comes down to, which I'm sure all of you are very fond of. Take a look at a couple different types of problems. The first one, solve x plus 2 over x equals 3. The first thing I like to do every time we're going to do one of these problems is I like to make note near the problem off to the side, and I'm going to say x cannot be 0 so that I know when I get down to the end of the problem, if I have 0, I know it's extraneous immediately. If I get other things, I do have to sub back in and check to make sure that it works. If I was solving this problem, the first thing I would do to get rid of everything in the denominator is multiply both sides of the equation by x. If I multiply everything by x, I'll end up with x squared plus 2 equals 3x. So I basically am multiplying the left side and the right side. X times x is x squared. Multiplying here, the x's go away, and that ends up being 3x. I have the makings of a quadratic equation. Move this guy over. X squared minus 3x plus 2 equals 0. We can factor this guy, I think, fairly easily, and we get x and x, factors of positive 2 that have a sum of negative 3 minus 2 minus 1. Finish it, x equals 2 or x equals 1. Check back to what we wrote up here. None of them are 0. Plug them back in. 2 plus 2 over 2. 2 plus 2 over 2 is that 3. Oh, you betcha. We're good to go with 2. And then 1 plus 2 over 1 is that 3. Yes, sirree. We have a correct answer. So this is the method of basically clearing the denominator, taking and multiplying by denominator, clear it out, go from there. Next type of problem. The first thing we need to do is recognize this is x minus 3. Therefore, I go off to the side and make note, x cannot be 3. I see x minus 1 in the denominator. Add that to the list. And we have this mess, which we should immediately factor. Now, most of the time with these problems, at least one of them is going to be over here. That's just the way that they're designed and worked out. So this factors into x minus 1 times x minus 3. What we need to do then is we can multiply by the greatest common factor of the three denominators. We've got this guy, we've got this guy, and we've got those two. So I'm going to multiply by x minus 1 times x minus 3. So if we go here, I'm going to multiply this 1 times x minus 3 and times x minus 1. I'm going to multiply this 2x times x minus 3 and x minus 1. And I'm going to multiply this guy by x minus 3 and x minus 1. What happens when I have this over x minus 3? These x minus 3's will cancel each other out, and I'm left with 1 times x minus 1 plus these x minus 1's cancel each other out. I end up with 2x times x minus 3, and over here those guys go away, These guys go away. I'm left with 2. So all we have left to do is put everything together. X minus 1 plus 2x squared minus 6x equals 2. I have a quadratic again. 2x squared out front. X minus 6x minus 5x. Bring this 2 over, and I get minus 3 equals 0. So I have a quadratic equation. Can we factor? Let's have a look-see. 2x and x. I've got negative 3, so one's plus and one's minus, and I've got a negative 5. It looks like if I put a minus 3 here and a positive 1 here, we might work out. 2x squared minus 6x plus 1x gives me my negative 5. 1 times negative 3 is 3. Finishing it off here, x for this one equals negative 1/2 for the 0, and this one x equals 3. We circle our answer, we say zippity-doo-dah, and we get points marked off because we can't forget to go up to our side up here and see that x is not allowed to be 3. Therefore, this guy is no good. It's extraneous. If I put x plus equals 3 back in the original problem, it doesn't work. My answer to this problem is x equals negative 1/2. So we've got 2 types of problems here. This one, you want to factor this guy, multiply everything by the denominator, and then this guy back here, we kind of multiplied through by the denominator. It's the same idea, nothing really canceled out, but we have to check our answer. You got to go back and check your answer when you're working on these problems. If you don't do that, you'll end up having x equals 3 be one of your solutions, and that's not good. Okay, you should be able to work on all of your homework from 2.1 all the way up to 2.7. Remember, the homework check is right around the corner.